Section 2.1, question 19. Let's take a look at how to find the domain of the function g of x equals the square root of x on the top divided by 3x squared plus 2x minus 1. So remember that when you're finding the domain, you're looking for two things that are happening here. One is that you can't have the denominator to equal 0 because then it will be undefined. And also on the top, you have an even radical. So you want the radicand to be non-negative. So let's address that first. So on the top, where you have the square root function, the even radical situation, you want all the stuff under the square root, which is just x in this case, to be greater than or equal to 0. So that's a key part. Then on the bottom, or the denominator, you don't want the function to be undefined. So you don't want 3x squared plus 2x minus 1 to be 0. So you want that to be non-zero. Now, this could factor, or we could use the quadratic formula, whichever works. Negative b plus or minus square root b squared minus 4ac all over 2 times a. So the discriminant, that would be 16. So that tells me that it would have factored, because it's a perfect square there. So I'm getting negative 1 and 1/3. Okay, so what we get from here is that x cannot be equal to negative 1 and 1/3. And at the same time, we also have from the numerator that x is greater than or equal to 0. So we need to put those together. Easily done with a number line. You're starting from 0 and going on. Except at 1/3, if this is 1/3, you have a pit stop, open hole. Negative 1 is not even part of this inequality, so x is not going to equal negative 1. We don't have to worry about it. So the interval notation for this is going to be brackets 0, 1/3, parentheses for that, union 1/3 to infinity. Hope that helps you.